Let's say we have 2x plus 1 all over x minus 3 all squared and x plus 1. Now if you watch, we have a distinct linear factor which is x plus 1. We have a repeated linear factor which is x minus 3. Now for us to solve this, we are going to combine the methods we used to solve for distinct linear factors and for repeated linear factor. Now this is equal to a all over. We'll start with for the distinct linear factor, which is x plus 1 plus, now we go with the repeated linear factor, b all over. For the first one, we are going to do the repeated linear factor when it is raised to power 1. So we have x minus 3 raised to power 1. Then when it is raised to power 2, we have c all over x minus 3 all raised to power 2. Now, the next thing is that we are going to collect the LCM of this value. So LCM of x plus 1, x minus 3 all squared is going to be x plus 1, x minus 3 all squared. Now, a trick that I used to remember the LCM is just, I look at the denominator of the fraction that we are changing to partial fraction, and I just repeat the same LCM for this one. So we have x plus 1, x minus 3 all raised to power 2. So the denominator goes into x plus 1 here. We'll be left with x minus 3 all raised to power 2, which is a into x minus 3 all raised to power 2 plus x plus 1, x minus 3 all raised to power 2 going to x minus 3. We'll be left with x plus 1, x minus 3. So we have b into x plus 1, x minus 3. So x plus 1, x minus 3 all raised to power 2 goes into x minus 3 all raised to power 2. So we'll be left with x plus 1. X plus 1 times c will have plus c plus c plus c into x plus 1. So I will write the left hand side, which is 2x plus 1 over x minus 3 all raised to power 2 x plus 1. So if you look, the denominator of both sides can cancel. So this cancels, so has gone. So now we have 2x plus 1 is equal to a into, now we can simplify x minus 3 all raised to power 2. So this is, we can expand it, we'll be having x minus 3 into x minus 3 plus, we can simplifying this, x times x. Okay, we have b into x times x, we have x squared. X times minus 3, we have minus 3x. 1 times x, we have plus x. 1 times minus 3, we have minus 3. Y for c, we have plus. C times x, we have cx. And c times 1, we have plus c. So now we simplify. So this is a into x times x, we have x squared. X times minus 3, we have minus 3x. Minus 3x, minus 3 times x, we have minus 3x. Minus 3 times minus 3, we have plus 9. So So plus b into this plus this minus 3x plus x, we have minus 2x. So we have x squared minus 2x minus 3 plus cx plus c. So this is equal to a into x squared minus 3x is minus 6x plus 9 plus b times x squared, you have bx squared. B times minus 2x, you have minus 2bx. B times minus 3, we have minus 3b plus cx plus c. So this is equal to a times x squared, we have ax squared. A times minus 6x, we have minus 6ax plus a times 9, we have a 9a plus bx squared minus 2bx minus 3b plus cx plus c. This is equal to. Now we are going to collect like terms. We'll bring the ones that have x squared one side, the ones that have only x one side, and the one that does not have x one side. So we have ax squared, we have bx squared, we don't have cx squared, so we have only ax squared and bx squared. So ax squared plus bx squared, and we have minus. So for the x, the one with only x, we have minus 6ax and minus 2bx, and we have cx. So we have plus, okay, we have minus 6ax minus 2bx plus cx. Then for the one without x, we have 9a and minus 3b and c. So we have plus 9a minus 3b plus c. So we are still going to be using comparison method to solve this. Remember, in our left hand side, we still have 2, we still have 2x plus. Now we are going to use comparison method to solve. So we say by comparison, we take the coefficient of x squared. So we have a and b are coefficient of x squared. If we look on the left hand side, we see that we don't have x squared. It means that the coefficient of x squared is 0. So we have a plus b for coefficient of x squared is equal to 0 when we are comparing it with the left hand side. Then y for coefficient of x in the left hand side is 2, but for that of the right hand side, this is what we have for coefficient of x. So we have minus 6a minus b plus c. We have minus 6a minus b. Okay, minus 6a minus 2b plus c is equal to 2. Then, for the coefficient of only the constant, for the constant, we have 9a minus 3b plus c. So we have 9a minus 3, 9a minus 3b plus c is equal to 1. So we can call this equation 1, can call this equation 2, and can call this equation 3. So we can now solve simultaneously. So from equation 1, since a plus b is equal to 0, that means a is equal to minus b if we take b to the other side. So we can put it into equation 2. Let's call this equation 4. So putting equation 4 into equation 2, we have minus 6 into minus b minus 2b plus c is equal to 2. So minus 6 minus b is going to be 6b minus 2b plus c is equal to 2. So this 6b minus 2b is 4b plus c is equal to 2. Now we can call this equation 5. Now still putting a to be minus b into equation 3. As putting equation 4 into equation 3, we'll be having 9 into minus b minus 3b plus c is equal to 1. So this is minus 9b minus 3b plus c is equal to 1. So minus 9b minus 3b is minus 12b plus c is equal to 1. So let's call this equation 6. We can now solve using elimination method for equation 5 and equation 6. So we can say 4b plus c is equal to 2 and minus 12b plus c is equal to 1. Now using elimination method, we can cancel out c by subtracting the two equations. So this minus this. So 4b minus minus 12b. That minus minus will change to plus. So we'll be having 4b plus 12b, which is going to give us 16b plus c minus c is 0 is equal to 2 minus 1 is 1. So therefore, we have 16b is equal to 1. That means b is equal to 1 over 16. So our b is 1 over 16. Now, we can put b as 1 over 16 into this equation. So we have 4 into 1 over 16 plus c is equal to 2. So 4 over 16 is 1 over 4 plus c is equal to 2. So that means that our c is equal to 2 minus 1 over 4. So c is equal to, taking the LCM of this, we have 4. 4 goes into 2, we have 8. 8 minus 4 into 4. 4 into 4, we have 1. 1 times 1, we have 1. So c is 7 over 4. So going back to equation 4, we say that A is equal to minus B. So A is equal to minus B. That means A is equal to minus 1 over 16. So therefore A is minus 1 over 16. So now we have been able to find the value of A, the value of C, and the value of B. So going back to the first partial fraction equation we had, we are going to put our values of A, B, and C into this equation. So we have 2x plus 1 all over x minus 3 all squared into x plus 1 is equal to A all over x plus 1 plus B all over x minus 3 plus C all over x minus 3 all squared. So our value of A is minus 1 over 16. So we have minus 1 over 16 all over x plus 1 plus our value of B is 1 over 16. So we have 1 over 16 all over x minus 3 plus our value of C is 7 over 4. So we have 7 over 4 all over x minus 3 all squared. So this is now going to be minus 1 over 16 will come down, 16 into x plus 1 plus 1 over 16 into x minus 3 plus 7 over 4 into x minus 3 all squared. So this is our value of the partial fraction of this fraction. So that's the final answer. You can still factorize out 1 over 4 from these fractions. So this is our answer.